welcome to this special time. Thanks, everybody. I have a funeral that I have to go to on Saturday, so I have to sort of drive down island tomorrow to do this. So I will not be able to record tomorrow, so we're recording today. So thank you. So if you're wondering what it is that you stumbled into, although at this strange time you had to have known that this was going to be a live episode of Astronomy Cast, that's what this is, a live episode of Astronomy Cast. We're going to take half an hour. We're going to record episode 494, all about icy moons, and then we are going to stick around and answer your questions about space and or astronomy.
Okay, I'm hearing that my audio is a bit harsher today. Let me know if it's a little bit better. I may have been eating my mic with a bit too much vigor.
I have you turned down about 3 decibels, but let me know. The mic is. You should explain why we have this experience, why the viewers are getting this experience.
So my office computer is set up for Twitch streaming with the good headset where I don't have to hear anything, or to being on Zoom with the good earphones and the crappy mic. So my options were no ears and mic, ears and bad mic, or 2 headsets simultaneously.
Yeah.
So I have my good mic headset around my neck and my
functional earpiece around your head.
Yes.
It's awesome. But and this is because you got some unintentional fiber optics installed at the home office.
Yeah.
Surprise. Better internet.
Yeah, we hope. So
Yeah.
I got a message a couple hours ago from my husband that boiled down to, oh my God, we're getting fiber installed right now. We won't have internet. Don't come home, record it at work. And I just got a message from him that because the connections at the front of our house are made out of copper, and the connections at the back of our house that are made out of things more modern than copper are out the back of our house, we may not be able to get fiber optics.
Oh, okay.
And it all comes down to our house gets its electricity and internet off of the street behind us, and the company that's running fiber only has permission for the street in front of us. And so both of our neighbors can get fiber, and it looks like we might not be able to.
They keep bringing fiber by where I live, and we've tried it out, and it's kind of meh. Yeah, our at this point our cable company delivers really fast internet. So, and the telephone company has, instead of saying like here's a gigabit internet, which I would pay for, I would gladly take gigabit internet. They're trying to sort of, I don't know, like compete exactly on the same market. And so it's like, yeah, it's not really any faster. It's got a bunch of problems. It's about the same price. I'm happy with my cable, even though there is fiber to my house, and I've tried it out. I went for a couple of months with both fiber and cable. Yeah. The fiber was mediocre, and then every time they keep coming back, I'm like, is it ridiculously better than the cable yet? And they're like, well, not really. Like, okay, well, thanks anyway. See you later. So there you go. That's my experience with. Tell us if you're listening. Your fiber offerings were mediocre.
Yeah, what we're dealing with is the front of our house, the utilities are buried. The back of the house, the utilities are on poles. And this means that every few years, a squirrel chews into our internet.
Yeah, we get rats here that do this. So, all right, I am ready to record. If you're ready to record,
I have to figure out where I hid my Audacity window. Hold on.
We can wait.
Thank you, everyone, for your patience. And I am now ready to press record. Wait. Yes, I'm ready to press record.
Okay, I'm going to press record. Are you sure?
I'm recording, and the levels look halfway decent.
Okay. My levels generally are mediocre. That's the part that I can't figure out. Anyway, hi, Chad. Apologies as always for my mediocre levels. Here we go. Astronomy Cast, episode 494. I want to do that again because you were laughing. Okay, hold on. Astronomy Cast, episode 494, Icy Moons Update. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, Dr. Pamela, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. So there's some congratulations in order.
I wasn't going to say anything.
Oh, I know. You've been really quiet about this, but for anyone who hasn't heard, Pamela has been inducted as the 2018 into the Academy of Podcasters Hall of Fame. Congratulations, Pamela.
Thank you so much, Fraser.
But
you have an asteroid named after you, so you still win.
Yeah. So as the host of Astronomy Cast, it's hilarious. So anyway, I'm sure it's for the slacker astronomy as opposed to this show.
Oh.
That's what it's got to be for. It's one of the first people. I've already figured it out. So yeah, no, congratulations.
Thank you.
All right, let's move on to the episode.
Wait, we have an announcement from the Weekly Space Hangout crew.
Oh yeah, like some kind of number.
Yeah, so the 500th episode of Astronomy Cast is only 6 episodes away. And our beloved friends over at the Weekly Space Hangout crew, they've done the math and they figured out that when you factor in our summer hiatus, 500 is going to land in the middle of September. And they're inviting everyone to come celebrate. They're inviting the fans, that's you, the viewers, the listeners, everyone, to Edwardsville, Illinois, the weekend of September 15th and 16th for a weekend of astronomy-related festivities culminating in the live recording of the 500th episode of Astronomy Cast. We're actually going to use the adorable little art house theater that's down the street from our ASP offices, and this makes me more happy than I can describe. You'll be meeting me, Fraser, along with a whole bunch of the folks from the Weekly Space Hangout crew, from the CosmoQuest crew, and recording live the 500th episode. And Fraser, I hear you're also going to put together a Q&A episode for Universe Today.
I am? Sure. That sounds good.
And we're going to work on other things. Like some of you guys know that I paint planets in my spare time. And I'm going to teach you how to paint planets too if you want to and you come. We're also considering outings to local attractions. We're going to be holding most of the events on Saturday at a brew pub. And if we can still walk Saturday night and the skies are clear, we're going to be doing stargazing.
Oh, that sounds great.
How
do people get involved?
There's going to be a registration going up Monday, June 4th on hopefully both the Weekly Space Hangout and Astronomy Cast. But go to astronomycast.com and check the menus, and I'll try and put a highlighted link in for you to find. So that's Monday, June 4th, which for all of you listening out in the podcast world is either today or has already happened. And for all of you watching live, just wait till Monday and you'll be able to sign up.
All right. Fantastic. And I'm sure we'll mention a couple more times before we reach the end of this season.
It's true.
Thanks to Cassini and other spacecraft, we've learned a tremendous amount about the icy worlds in the solar system, from Jupiter's Europa to Saturn's Enceladus to Pluto's Charon, geysers, food for bacteria, potential oceans under the ice, and more. What new things have we learned about these places? What new things have we learned about these places?
They're weird.
They're weird and they're awesome. And there's a lot of them.
Yes.
Go ahead.
Yeah, I don't even know where to start on this.
Well, actually, I guess what was the state of our knowledge when we first tackled icy moons, which was in the 50s when we did our tour through the solar system and talked about Jupiter's moons?
At that point, we suspected that Triton, the moon of Neptune, might be a stolen Kuiper Belt object. We knew that Europa appeared to have subsurface oceans, but I'm pretty sure that was even before the Cassini discovery of Enceladus's geysers that we first discussed this. And so this whole revolution that you look at a world and it probably has a subsurface ocean, that's entirely new since we started creating this show.
And is now feels like it's the vast number of places where the potential for life in the universe is worlds like this. It's not the habitable planets that we've always come to think of them, the rocky worlds in the habitable zone of an Earth-sized, Earth-like star. It's the probably 1,000 times as many worlds, these icy worlds across the, per solar system, that there could be 1,000 times as many places to look for life in the solar system as just a plain old boring rocky planet like Earth.
Yeah, that whole Goldilocks zone around a star, that is far too limiting. We have moved on from that.
Yeah, that is an old idea. Many more places to look for life. Really hard, complicated, difficult places to look for life. I mean, these are not easy places to go to.
But we seem to have found one that we shouldn't look. Only one.
What?
So...
What? You're telling me there's a place we shouldn't look? What?
Well, so I was reviewing Icy Moons today in preparation for this show, and I came across, as I was reading about Callista, basically it's this one lone overly cratered moon, and the way you get a surface as beat up as this particular moon's surface is you have nothing interesting going on your insides. So in trying to figure out exactly why it is that Callisto is this weird oddity that it is, I did some diving. And it's thought that Callisto may have simply accreted with small things adding up over time. And it did it in such a way that it didn't end up with the differentiation that we see with other worlds. It doesn't really have a core. It doesn't really have a liquid ocean. It's just basically a giant snowball that has had a whole lot of stuff beaten into its surface over the eons.
Poor Callisto.
Poor Callisto.
Yeah, although we could say that kind of thing about so many of the worlds in the solar system, just the smashing and late heavy bombardment.
But most things that get this big tend to have subsurface oceans. We look at Enceladus, we look at Europa. We even think Ganymede probably has a subsurface ocean. Triton has ice geysers.
Titan could potentially have its own subsurface ocean underneath its surface oceans of methane
and ethane
and ammonia. All right. Well, so let's take a look then. What is sort of the picture as we understand it now for a lot of these icy worlds across the solar system? What would one of these look like, especially if you could kind of slice them open?
For the most part, they have a roughly rocky core surrounded by who knows what, dense materials, but probably a mixture of things that don't melt readily. Then on top of this, you have a liquid ocean, and on top of this, you have frozen solids. In some cases, like Pluto and Triton, we see vast frozen nitrogen surfaces. We see all kinds of frozen gases on the surface, including frozen water ice, it appears. So the surfaces themselves basically have a mixture reminiscent of our own planet's atmosphere. The ratios are different, but it's basically the same kinds of stuff. And then beneath that, we think is like good old H2O water oceans that may be a different salinity, a different pH due to stuff in the water. but we think these are water oceans.
So then what is keeping these oceans liquid?
Different theories for different worlds. And this is one of the new things that is so hard for us to understand. It's amazing having problems like this. With Europa, it's straightforward. Europa is in a resonance with the other Galilean moons as it goes round and round Jupiter. And thanks to tidal squishing and expansion that it undergoes on a regular basis, it has heat building up in its core. It probably has subsurface volcanism, just like we have underneath our own oceans. And that isn't sufficient to generate heat to keep it liquid all the way to the surface. Plus, the surface is vacuum. And so, with that combination of not a lot of heat and vacuum at the surface, you end up with these ices at the surface. The factors that determine if something like nitrogen, something like water is a solid, liquid, or a gas, is the combination of the pressure it's under, the temperature it's at, and at different values, you get different things. And with no surface pressure, you're pretty much limited to solid or gas that's running away rather quickly.
But I mean, I think when you think about all of the different environments, right? You've got places like Europa.
Pluto.
Well, sure, but I mean the ones that just make more sense. You have like Europa, which is within really under the tidal influence of Jupiter. You can understand how you've got that kind of flexing. And when you saw what happened to Io, it's volcanism and secret protomolecule research labs, but it's volcanism, and then you look at Europa and it's got all of these, it's a little cooler, but so the water has melted and you don't have the volcanism, and then you could see sort of that same process happening with Ganymede and Callisto, and then similar versions of that happening with the Saturnian system. But now the thinking is that even, as you said, Triton, Pluto, Charon, Sedna, all of these worlds out there have some amount of liquid water. So, I mean, is it radioactivity? I mean, is it just it hasn't cooled down yet since the formation of the solar system?
We're still trying to come up with one solid theory, and it could be different models matched better or worse for different worlds. But the kinds of factors that we have to take into account are how much radioactive material is there within the world that is still undergoing normal everyday radioactive decay and giving off heat in the process. We also have to look at if a world is in an elliptical orbit, that being in an elliptical orbit will cause the forces it experiences to change over time and can, to a different degree, drive internal heating. There also may be questions about its collisional history. If you smack the bejesus out of a world and Mimas, which is the moon that looks most like a Death Star, it has cracks running through it. It almost got knocked to pieces. And in a different kind of object, massive collisions like that have the potential to generate sufficient heat to melt the interior somewhat.
One of the things that's pretty fascinating, this is fairly new research that came out this year or last year, was that it appears that the sort of the core of Enceladus is more sponge-like than sort of a solid rocky. Your traditional expectation is that the core of Enceladus and Europa and these places are just this sort of rocky ball surrounded by this ocean and then surrounded by this icy shell. And now it looks like it's probably more sponge-like, and that you've got, say, these tidal forces are squeezing the water through the center of the world, keeping it liquid and sort of allowing it to maintain potentially this liquid state for much longer.
And
go ahead.
And each world may have, like I said, a slightly different solution. And the fact that we're seeing this across a whole variety of masses and radiuses tells us this isn't going to be something simple to figure out. We look at a world like Ganymede, which is bigger than Mercury, and it's easy to imagine it having internal tectonic activity. It's easier to imagine it, given all the tidal forces of Jupiter, maintaining liquid. But you look at something so much smaller like Enceladus, and you have to start looking for new solutions.
And so one of the probably the most exciting discoveries, and this is fairly recent as well, is this discovery of hydrogen gas, which is coming out of the geysers that are on Enceladus. And why is that so important?
Well, hydrogen gas gives us a hint at the internal chemical structure. And this tells us that it's possible for there to be all sorts of complex molecules, essentially the building blocks for life, down inside this world. Now is going to be the question, do we find similar with Europa,
Right.
with the Europa Clipper going out in the future?
Yeah, I mean, it's food for bacteria on Earth. This gas, in the oceans is what a lot of that the base of the food chain at the bottoms of the Earth oceans feed off of. And so to find this in Enceladus as well is to say, okay, there's water, there's food for bacteria, there's food for life there.
Well, hydrogen by itself isn't really a good food source. It's all the complicated molecules that it's part of the formations of. And you and I are included in the complicated things that hydrogen is part of the formation of.
And that bacteria like to eat.
Well,
Yeah.
yes, that's true as well. That is true as well.
Yeah. And so the question is just, is there an actual ecosystem but all the conditions are there for there to be an ecosystem, even
Yes.
though potentially. So let's talk a little bit about sort of what the plans are then to try to explore some of these worlds a little better.
Well, they're not as rich and complicated as we might wish. Currently, there continues to be call upon call to send a mission out to Uranus or Neptune. There are some in the exploratory phases, but nothing solidly on the books, as we have a spacecraft with funding dedicated and instruments selected. And that kind of a mission would allow us potentially to get a better look at Triton, which is, again, an exceedingly large moon. And its surface is what we expected to see when we got to Pluto. It has cracks. It has what's called cantaloupe textured terrain, which is the results of frozen patterns in the surface ice. And the cracks are something like the chaotic terrain that we see on Europa. This is another world that has geysers that have been seen. We don't really understand Uranus and Neptune. And only by sending out more missions to the outer solar system, which again is something that's being called for, something that's being explored, but something that's not definitively funded. Only by taking that step and funding it and launching something are we going to be able to make sense of what else is out there. Now, what is funded, what does have its instruments selected, is a mission to Europa. This particular mission, the Europa Clipper, it isn't going to land. In fact, it's going to do a pretty good job of keeping itself fairly far away from the surface. It's not even going to go quite as close as was done by the Galileo space probe, but it is carrying with it the ability to carefully map out differences in density. It's carrying radar equipment. It is going to let us finally answer questions about, is the surface ice 10 kilometers thick? Is it 100 kilometers thick? Does it vary from point to point? These are the things we'll finally be able to answer.
I've heard that with this year's budget, they are considering bolting a lander onto it again. So,
oh, really?
Yeah. So the lander had been removed, and then I've heard rumors that potentially the lander might come back, which would be really exciting. I mean, a close orbiter that's going to go and check out Europa and take pictures of the surface finally is going to be so great, but to actually have a lander go down and maybe sample some of the material on the surface is going to be great. Just passing through those geysers that are emanating from the surface. One really fascinating discovery, I don't know if you had seen this recently, was that the data for the Europa geysers was in
Galileo
Galileo's data all
the
along.
magnetometer.
Yeah.
They've recently reprocessed data from the magnetometer using a completely different way of looking at it. They'd noticed back in, I guess that would have been late 90s, early 2000s, a weird spike in the magnetometer data, and it was kind of flagged as an anomaly. And in light of the Hubble observations showing geysers, we believe, at Europa, they went through the data again. And you can explain this anomaly as the effects of flying through moisture.
Yeah.
It's just awesome.
Yeah, I mean, and I think we've mentioned this in the past, how many amazing discoveries are there in the data. You just don't know what to look for. And so it took someone saying, I wonder if there's any confirmation that the data for those geysers was in the Galileo mission, because they didn't know to look for it back when Galileo was there. Otherwise, they would have done more intense readings.
And technology changes. And I just earlier today, preparing for this mission, was looking at Triton images that I hadn't looked at in probably over a decade. And thanks to advancements and the hard work of so many of the amateurs at unmanned spaceflight, who might as well at this point be called professional image analyzers, we have whole new views on Triton from the same data that was taken when we were kids.
I love that you referred to this episode of Astronomy Cast as a mission that you were preparing for. But two, I mean, that is a bittersweet concept. That what do we know that's new about Triton, the moon of Neptune, since we did our last episode? And sadly, almost nothing, because there has been no return missions to Triton. It is to Neptune, to Uranus, to either of those worlds. They're super fascinating, and yet we've only seen this one flyby from the Voyager, and that's it. And there's no more plans in the works, as you mentioned. There's no more plans in the works to go back to either of those worlds.
And our only new data that we have for any of Jupiter's satellites comes from Hubble.
Yeah. That old thing?
Yeah. It's now old enough to drink.
I believe it's old enough to retire. No. or at least, after it got its glasses. It's been 97 was when it got the fix. Yeah.
I don't remember.
Yeah, no, it's older than that.
Well,
95. It launched in 95.
No, it launched when I was in high school. It was 91, I think.
Oh, now we're Googling.
Welcome to the land of not knowing everything, which is where we live constantly.
I'm sure Chad will hackle. Oh, wait, 1990. You're right.
I told you, 90 or 91.
There you go, 90. So
10th grade.
Yeah, so it's 28 years. 28
good
years.
Lord.
Yeah.
Old enough to have a PhD.
Yeah. Not old enough to drink. Old enough to rent a car. Old enough to have a PhD. Old enough to, be buying its first home. Yeah. No, that's so we can't wait for James Webb. So what are some other interesting sort of updates that you've found about some of the icy moons in the solar system?
I think the most interesting one for me is in some ways the silliest. It's been finally confirmed, thanks to Cassini's hard work after so many years in orbits, that some of those rings are indeed being fed by geysers coming off of moon. It is shown definitively that the gaps we see in the rings are because some moons are more effective than sheepdogs at herding. And we're also learning that some of these moons are basically rubble piles that are loosely held together by their own gravity. Mimas, like I said, has cracks all the way through it. And as we look through the moons, we see sponges, we see things like Callisto that are built up from snowball after snowball getting packed together and then packed with cratering over millennia. This variation and this capability it's rich. When we say icy moons, that covers everything from small misshapen things like Pan, which we now know from models was probably formed from two similarly sized objects combining in such a way that their angular momentum made a ravioli. To icy moons include Titan with its rich atmosphere and surface of methane that exists at the triple point where it is rain, it is gas, it is oceans, it is snow. We have icy moons like all the other ones we've talked about in this episode.
It almost feels like when you think about sort of how much of the solar system is this ice, that pretty much once you make it through halfway through the asteroid belt, you get to the moons of Jupiter, all the other objects, all the other moons, everything else from that point out is all variations on this kind of object. And these objects are so far away, so they're really hard to study. I mean, we've only had a chance to view a few of them up close and really not get a sense of how they're similar, how they're different, that there probably are many different classifications for them, but we just haven't sampled enough and really explored enough of the outer solar system to be able to know what's out there. It's so far and it's so hard to get to that every little scrap of information that we get is worth its weight in gold.
And one of the most tantalizing things to think about is the asteroids are so close to the sun that they don't really have the opportunity anymore for most of them to have a ocean or a layer of ice on the surface. We know that Ceres probably has internal water, yet again, theme of our solar system. But in general, we're looking at a continuum of objects that go from these small carbon-rich, carbonaceous chondrites through to worlds like Pluto that essentially have an asteroid core surrounded by water and ice. Now imagine if we took all of these Kuiper Belt objects and melted them down to see what's inside. We might essentially find another asteroid belt. The question is, what exactly is the continuum? How exactly do we understand how these objects formed in the early solar nebula, given the different temperatures that appeared at different distances? And are the asteroids nothing more than essentially what could have been Kuiper Belt objects that got flung into the inner solar system when Jupiter and Saturn were busy flinging things around? It's going to be amazing what happens in the next decades as we continue to try and understand solar systems by studying all the ones we've now found other than our own.
This part of the solar system is not going to give up its secrets easily.
No.
All right. Thanks, Pamela. We'll see you next week.
Sounds good, Fraser.
All right.
And now we save.
Don't go anywhere. 494.
Thank you. And it just started pouring rain.
Oh, really? We could have some bad weather here. All right, I'm done. I'm safe. All right, Reddit C Brazil asks, why send a flyby mission to Pluto and not send a Cassini like mission to Uranus or Neptune instead?
Because the mission we sent to Pluto let us see something we had never ever seen before.
Now,
And
what
even
about a return mission, though?
a return mission to Pluto?
Mm-hmm.
The energy requirements on that are beyond
No,
what we can conceivably.
Alan Stern is in the process of planning another mission to Pluto.
I know.
So there are plans in the works. So why go back to Pluto instead of going back to Uranus and Neptune?
So this is where I'm going to point out that the Decadal Survey, which was put out by the entire planetary science community, has made a call as a community to send a mission to either Uranus, Neptune, or both to further study these very not understood worlds. Alan Stern is one human being who's accomplished great things in his career.
Yeah.
And he is lobbying really hard to go back to Pluto again.
Yeah.
But he personally vested in that.
Yeah.
As a whole, the entire community recognizes we have massive gaps in our understanding, and we probably need to systematically address the gaps. And this is why we do work from a decadal survey. And it's led out of the National Academies of Science, and both the National Science Foundation, NASA, and other governmental agencies take their lead on how to distribute funding from these community recommendations.
I think that, I mean, one, I bristle at the question at all. Why choose, right? Why?
Because we fund a military.
Yeah, like people smoke cigarettes. Don't smoke cigarettes, and then we can have a mission to both places. Don't
or smoke more cigarettes and use the tax money to fund
sure,
NASA.
Right? So the point is that the choices between these missions are sort of an artificial construct. Same thing with people like, we shouldn't spend our money on human missions. We should spend our money on robotic missions, and vice versa. Like, it's just like that whole argument is sucks that we even have to have it. And so I refuse to even have that conversation, right? Like just the premise of it is that we should be choosing between those kinds of things is so infuriating to me. No offense, but it's like, I don't want to have to choose. I'm not going to.
So when I was in Japan for the Communicating Astronomy to the Public meeting a couple months ago, one of the things that really struck me is how amazing the infrastructure was. And where I live, we have crumbling bridges and internet that gets chewed by squirrels. I'm sure they do that too, but it actually gets fixed. And it really made me reflect on what's possible when you redistribute the income of your nation in radically different ways. But this is the truth of the system we're in.
Yep.
And I'm just glad that Japan also builds telescopes.
Where are we at with the Decadal Survey now? I mean, there's another one just around the corner, right?
There should be. I'm actually somewhat confused that I haven't heard of committees being convened yet. I'd
heard that they were potentially going to delay it, and then it was brought back. So
yeah, it's normally something that is well along in the planning at this point.
So NASA dropped requests to delay the next astrophysics decadal.
Okay.
Yeah. So they had originally said that they should maybe wait a little while to get working on the 2020, and then they dropped that request, so they're going to be starting it soon.
Okay. I want to say it normally would have been started by this point.
Yeah. So they have not selected any members of the committee for Astro 2020 yet, but they're going to pick their survey chair by December, followed by the rest of the committee and any subpanels that can support the effort. So we should see the 2020 decadal survey get cranking by the end of this year.
I hope.
You were on the last one, right? You
Yeah.
got involved in the last one.
Yeah, I was in one of the committees. And we'll see if I'm in one of the committees again. it is what it is. Uh, the situation is very different now than it was back in 2008, 2009.
Arjone asks, can there be one rocket with multiple missions on it, or would that be too expensive if there was an explosion?
That is called the last Falcon 9 launch.
Yeah. Yeah.
The last Falcon 9 launch had the Grace follow-on mission, which was 2 spacecraft launched simultaneously, as well as a bunch of Iridium satellites. And we've done stuff like this before. When LRO, Lunar Reconnaissance Orbiter, launched back in 2009, it carried with it the LROC mission that collided into the moon and sent back data. So that was, again, 2 spacecraft that did 2 different things, and they both went to the moon. We currently have, with the InSight mission, there's the main satellite as well as 2 suitcase-sized. They're calling them CanSats, but really they're suitcase sats.
The CubeSats.
Yeah, so Mars A and Mars B.
Marco and I'm going to say Polo, but I don't think so.
I don't remember what they
named them, like Eve and the characters from
Portal?
No. Man, my brain is mush. The Pixar movie.
Oh, WALL-E.
WALL-E, yeah.
Going to share the rain that is currently occurring with you.
Oh, that's nice.
We are having one of those, I'm really going to procrastinate on going home today kind of rainstorms.
Your garden will appreciate it.
My garden will, but there's a bike behind me. So
I've been to your office. It's not that far from your house. You can make it.
No, it's true. It's true.
Yeah, there you go. So the issue, so you're talking about with this new Falcon 9 that just launched was they had, I believe they had 7 satellites on board. They had the Grace mission, and they had a bunch of commercial launches, and the spacecraft, or this rocket, was able to deliver the spacecraft into different orbits, similar-ish orbits, but different orbits. It put the Grace mission into a low Earth orbit. It was able to put other satellites into, as best it could. And so it's not about the explosion and putting all your risks together. It's just how much do you want all of your satellites to go to the same place?
And with the Falcon 9, they were able to go up to 300 miles, do a maneuver, launch the 2 Grace mission craft, then fire their engines, go up to 500 miles, and launch the Iridiums. When we're doing an interplanetary launch, you don't pause. You put your foot to the throttle, you pull it back a little bit when you hit the highest, I'm losing the word for it, that point in takeoff where you're vibrating the bejesus out of your spacecraft, so you pull back on the throttle a little. And
maximum dynamic pressure.
Yeah. And then you just floor it the rest of the way out. They often launch little tiny spacecraft, and InSight was kind of tiny on giant rockets so that they can have the best possible fuel to weight ratio. If you're trying to go to the outer solar system, you're going to want to, folks are reminding me of what the term I forgot was, max Q. This is where you pull back on the throttle. So when you're going to the outer solar system, you're going to want to get as much velocity as you can out of your spacecraft before you even leave Earth's orbit, and you just go straight out of Earth's orbit without stopping.
Yep. We
do piggyback things. We had the Huygens probe on Cassini. We had the begins with the letter P, Philae, that landed, that flew with Rosetta. We sent the Beagle with Mars Reconnaissance Orbiter, I believe. So there's this consistency of doing what weight limitations allow us to do. But it comes to the matter of, do you want to be in similar orbits? Because you don't want to change what orbital plane you're in. That's way too much energy. Yeah. And how much velocity do you need to get out of your rocket?
Yeah. And so they often launch 20 or 30, or have launched 30 CubeSats all at the same time, but they're all
Yes.
going to precisely the same orbit, and then they're
And
being
it kind of
released.
looks like a flower girl scattering petals the way it
Right.
happens.
Yeah. Yeah.
It's just CubeSats for you, CubeSats for you,
Right. Right.
CubeSats for
Yeah.
everyone.
And I mean, as we move forward, you may see more of these sort of interesting opportunities where they can put two missions together, launch them to two different trajectories, but it's all just going to come down to cost. How much of your rocket energy do you want to burn to try and change orbits to, just imagine it is like doing a carpool, right? And you've got your car and you got a bunch of people in your car, and if the people live kind of close together, then it totally makes sense. And if they live far apart, then you'd be burning a lot of gas to take the people to drop them all off at all their different locations. And it's the same thing with a rocket, except times 1,000.
Yeah, exactly.
Esther Gagne, are there any plans for developing laser-propelled microprobes for the exploration of the inner solar system instead of Alpha Centauri? Like, so Project Starshot, but for the solar system.
So going into the inner solar system, you run the risk of firing a lot of things at the sun. There are a lot of thoughts, models, workups, especially from people like the Planetary Society, to use light sails on smaller spacecraft to explore the inner solar system. But in terms of these microsatellites, going in seems to be the wrong direction. But it will have to be tried within our solar system before we try and escape our solar system. Just go with the other direction.
But we did a whole episode on solar sails, and one of the really fascinating concepts that you had brought up that was a genuine surprise to me was how you can use a solar sail to lower your orbit closer to the sun, as well as be pushed away from the sun. Like you can go both directions in the solar system.
Yes. But if you instead have one of these laser propelled microprobes, there's no way of firing engines in the other direction to prevent death by sun.
Right. But the sun, in order to actually reach the sun, you'd have to cancel out the 30 kilometers per second of orbital momentum or orbital velocity that you already have. So if you, faced down orbit from the Earth and accelerated this thing, you would be canceling out chunks of the Earth's orbit, and so in theory you would lower its orbit and it would make its way closer to the sun, but then it would be on some new comet-like orbit around the sun, right?
Right.
Not a useful circularized orbit.
No. And since you can only fire at it from the Earth, you are very limited on how you can adjust its orbit.
Arjun says, will the next generation of rockets allow for more deep space exploration of the outer solar system, planets, and moons?
We hope so. Elon Musk has his focus very tightly on Mars, but Space Launch Systems also has their goals tightly set on Mars. But at least with Elon Musk, he's going to sell those things commercially, which means NASA can purchase them and NASA can use them and ESA can use them, and whoever has the dollars, the euros, the yen can use them to go to the outer solar system.
If you want to put a new crater on Pluto,
you could do it.
Elon Musk will sell you a Falcon Heavy and you can throw 3,500 kilograms right at Pluto. So that's a bigger mission than, I don't know what the weight of New Horizons was. I'm now going to look that up. But that would be a mission. Oh, there you go. So New Horizons is 401 kilograms. So you could launch a spacecraft almost 10 times the mass of New Horizons to Pluto on a Falcon Heavy. You could send a mission that could send a orbiter and a lander to either Uranus or Neptune, and you could even send a mission that could do both.
And to give you a sense of scale on just how tiny that is for New Horizons weighs substantially less than your average horse and about what a pony weighs.
So if you've got $90 million and you want to send your own mission to Pluto, talk to Elon Musk. He'll hook you
And
up.
you can send something bigger than a horse.
Yeah, what's their launch to? Oh, he doesn't say to Uranus, but you could drop 16,800 kilograms onto Mars.
Yeah.
So 16,800 kilograms of people, of colonists, just fire them at Mars, wish them luck. Benlow asks, can anything exist in liquid form in space? Vacuum, zero gravity. That's a great question. Wait a second. Nothing? What about Mercury?
It sublimates.
So Mercury will turn into a gas. So there is a vacuum pressure, there is no substance whatsoever that you could put into the vacuum of space that wouldn't sublimate away. All right.
Vacuum is a harsh mistress.
It really is. Oh, I like that. I like that question. Ben Appleby asks, how would liquid water act with Mars' low gravity? Would I be able to drink out of a normal cup on Mars? No, but in your habitat.
Oh, in your habitat, you're fine. The gravity doesn't matter. It will just, you'll get more domey water, for lack of a better word.
Yeah.
So surface tension will allow water to dome up more on Mars than it does here. It's not going to float out of your cup like they worry about on the International Space Station.
Right.
But as long as you're in a habitat that's fully pressurized and at a reasonable temperature, as long as you stay below 100 degrees Celsius, you're fine.
NASA did a bunch of really interesting experiments with artificial gravity. They put people on these rotating wheels, but they suspended them from the side, and so then they canceled all their Earth gravity, and so then they just had the rotational gravity from going around in this wheel. And what they found, then they had them do tasks. So they had them like try to walk around and try to perform various basic, like, shuffling paperwork around on a desk and stuff. And they found that at around 10%, you're useless. Right? You just can't get anything done. That everything now, maybe you could get used to it in the same way that the astronauts can become accustomed to zero gravity, but and that you can it's really hard to even walk around up to about 15% gravity, which is why the astronauts had such a hard time walking around on the moon. And so you would have a really hard time just getting around in that kind of low gravity and just performing basic actions of just like sitting at your desk and typing on the keyboard and moving papers around and going upstairs and setting the dishes on the table. Like all of that stuff in that lower gravity is a mental exercise. So it would be pretty fascinating to sort of see what it would be like to just like drink a cup of coffee. I'm sure the first few times you did it, you would totally get it all over yourself.
It makes sense though. Have you ever been playing a video game with overly sensitive controls? I was trying out a game on Phoenix's Oculus Rift, and we set it to work off of real physics instead of the pseudophysics. And suddenly all the thrusters mattered. And the slightest movement, and I was spiraling out of control. And reality is like that video game that's set to being a little too sensitive. And this is why so much training, or in the case of the video game, practice is required.
Gordon says you should try some fluid painting in low gravity.
That would not work very well.
Or really well. It'd be like a new kind of art. Let's see. And Paranor is saying you should just use sippy cups on Mars. I wouldn't be surprised
I
if
agree.
everybody's using sippy cups. You're going to have your coffee cup with that little sippy cup top to any beverage that you're going to be drinking. Yeah.
Well, travel mugs become the new thing that you use for everything.
For everything, yeah. Yeah, because you think about it, just like when things spill here, in 1G, imagine how they're going to spill in 0.3G or point.
They'll bounce.
Yeah.
Imagine knocking your coffee over and having a big old blob of coffee hit you in the face.
Yeah. Oh,
Hot
yeah.
liquid is
Yeah.
dangerous.
Or like
in
just
two
accidentally
ways.
banging the table and having, whatever was on your plate just flying up into the air and all over you. Yeah. Yeah. I think Elon Musk, you've got to listen to us. This is the danger.
He's not listening to our podcast.
All right. All right.
No.
All right. So we're just about to wrap things up. The fluid painting, though, I believe was a opportunity for you to mention some of the painting that you've been doing over on Twitch.
Oh, that is true. So I do artwork. The only ones I have in my office are attached to the wall and not well lit. I paint planets and discuss the science that could or couldn't form the things that I'm painting on twitch.tv/starstrider with a Y, most Saturdays at 4 p.m. Eastern, which is 9 p.m. London and 1 p.m. Pacific. And you're all invited to hang out on the internet with me, make art, and talk science.
Well, and so now before we wrap up today's episode, a big thank you to the Weekly Space Hangout crew. They've been sort of over in the chat.
Yes.
Promoting the Weekly Space Hangout crew. This is, of course, the chat that's down below at the bottom of the screen, and it's really the community that surrounds and supports everything that we do. So if you want to be a part of this community, go to wshcrew.space. You've got direct access to Pamela and myself. This is where they're planning our 500th episode. So if you want to be a part of that community, it's free. Just join up, and they would love to have you. And if you want people to hang out with over the dark times of the summer while we're gone on hiatus until September, this is where you're going to want to go. All right. Well, thanks, Pamela. Thanks to everyone in the chat. Thanks to the WSH crew, and we will see you all next week.
See ya.